Yeah. The recording has started. Once the recording will start, let me know.
Yes, sir. Recording is started.
Yeah. Good morning to all of you. Let us see in the today probably we are going to uh, put a temporary end for the central course. Many things we have discussed. And what is the time we have decided that we should take the test on central course? That is on Friday, coming Friday. This coming Friday, right? What is the date? It has been given in the WhatsApp. Check and let me. By that time, I'll open my whiteboard.
Sir, on Thursday, sir.
Can you email? Just let me know this thing. Magazine Friday. I think 71, 70. 71 is a free page. Class 6. Okay. So the first thing we'll pose with a warm up. By the way, how many of them has appeared so far? 6. Not bad. So we'll pose with a question immediately. That will be our warm up. Suppose a particle is moving in an inverse square law. In an elliptical orbit. Elliptical orbit. Compute the velocity of the particle as a function of k, that is the constant, m, the semi-major axis a, and of course r, the variable is r. Yeah. Did you understand the question? Let me know. The question is clear. The particle is moving in a elliptical path. Suppose the particle is moving in a elliptical path. This is A. The particle is moving in this.
Sir,
the particle has mass A. Yes, tell me.
the m is the mass of the particle, sir. Particle or the reduced mass?
Think of it as m reduced much. Maybe particle. Let me rather writing than m. So let me put it as mu. Yeah. That will be much more. In that case, how do you calculate the velocity of the particle? You can see the notes, what we have done already. We'll take Maximum 2 minutes or 3 minutes. How do you calculate the velocity? How do you know the velocity? If I need to know, from class 2 level thing, try to think how you wanted to know the velocity. If you have the total, suppose you know the total energy. Total energy. Total energy is equal to kinetic energy plus potential energy. Now tell me, what is the total energy? Notation you write. What is the notation for the total energy? Yeah. Are you Lakshmi? What is the notation for the total energy? Right? Am I audible or am I disconnected? Are you Lakshmi? Can you hear me?
Sir,
Daniel, are you? Yeah. What is the notation for the total energy? Am I audible? I guess some
Okay.
problem.
Okay.
Yes, sir, you're audible. But she is not audible, sir.
Okay. So
E
Arya, can you?
is
Okay. And kinetic energy for the system will be what? Kinetic energy of the system with a reduced mass mu. What will be the kinetic energy?
half mu r square.
Half mu. Then half mu. After that, what is half mu? After that, what? Kinetic energy of a mass m velocity v. What is that? Anybody else? Mahalakshmi? What will be the kinetic energy? Can you tell me? Are you there, Mahalakshmi, or sleeping? Am I audible? Yeah.
hello.
Sir, you're audible.
So any one of Rami, yeah, Rami or Renuka, anybody, just can tell what is now. What should I write? The kinetic energy is what? And nobody voice is audible, so I do not know. It is the problem in the network.
Her voice is breaking, sir.
Anybody can.
So
My
r
voice is
dot
breaking.
square.
No,
R
not
dot
you.
Instead
square
of yeah, instead of r dot square, I'm writing this.
v square.
But yeah. So yeah. Now, and potential energy already I have said it is the inverse coil law. So what will be the potential?
K by r.
Minus k by r, because it is attractive. Minus k by r. So this is enough. This is enough. This is small v. So this is enough. Now tell me, in elliptical path we already know. Recap. We already know what is e for elliptical path. Yes.
The L square by 2 mu r square part.
Which one?
Uh, for energy, total energy.
That is hiding inside this v, na? I have not written it in
Okay,
terms of polar
okay,
force.
sir. Okay, sir, got it.
That is when she said r dot square, I am saying instead of r dot square, write it v square because I need the total component. Now, for the elliptical path, what is E? You have calculated 1 day ago or 2 days ago. Can you tell me?
Minus k by 2a.
Yes, correct. So minus k by 2a. So once this is given, I think everything else is known. You don't need to do anything else. So it is a, that's why I said it is a one-line problem. Provided, of course, this part is not one line. Doing this itself, it took a long time. So this is, I told you as a recap. So minus capital K by 2a is equal to half v square minus k by r. So it will be what? Half mu v square is equal to k by r minus k by 2a. Is it correct? Is it okay?
Yes, sir.
So v square is equal to 2 by mu k by r minus k by 2a. So k I can take common inside and k by mu is there. So it will be 2 by r minus 1 by. So I can compute v exactly root under that. So better I keep v square is write that. Yeah, better I write v square at this format. Yeah. Is it clear? Quite easy, but you have to correlate many things. This the main chunk of the work. What we have not done is computing this, which I have taken it granted because we have done it already. Is it clear? This problem is it clear, everybody?
Yes, sir.
Yeah. So that's how you have to solve the problem. I think in the previous class, actually, I have also given if the eccentricity is this, how much, which is the velocity. I hope you have done that. So mostly this is easy problem. So this is one of the thing, and let me see what is the ultimate format. I have written that third one. Yes. Yeah, I have written it in this format of uh, t is equal to, I have written it, t square is equal to 4 pi square 4 pi square aq, and there will be mu by k. So mu by k, so let's take it. From here there will be one problem can be coming, quite easy thing. Next part you can do it. Kepler's third law revisited. We will write the form in this way. T square is equal to pi square. That what is there, Daniel?
The screen is not visible, sir. Screen is not updated.
Screen is not up. Let me see. There is a bad network quality. Yeah. Wait for something. Morning itself, I do not know how these things happen. Everywhere it is a signal problem. Is it visible now? The
No,
screen,
sir.
nobody is
Still not
talking, then
updated,
why is
sir.
the screen still not updated? So let me close it once. Means the moment I close it, I do not know whether I can share it next time or not. Okay, let me try. Yeah, at least it is. Yeah, I joined once again now, but this thing is gone as usual. Wait for a moment. I am trying to share the whiteboard, but it is not appearing so far. Yeah, I have shared it from my side. Let me know whether it is visible on your side or not.
Yes, sir, visible, sir.
Is it updated? Kepler's third law revisited?
Yes, sir.
Yes, sir.
So tell me then 4 pi square a cube. Then after that, what should I write? We have done it in the previous class. Daniel, or anybody can tell. No particular person.
Sir, mu squared by k.
Mu by
Mu
by k.
mu by
K.
mu by k. Now, particularly this, so that is how we say that from here t is proportional to a. This is we used to say. That is all okay, but let us particularly see for this case elliptical orbit, and k is equal to, let's say, k is equal to g m1 m2, particularly for this inverse square law. And mu, what is mu? Can anybody tell me? For mass m1 and m2, earth is, let's say, m1 is earth, m1 is earth mass, and m2 is sun, solar mass. What is mu? Can anybody tell me? The reduced mass. What is the reduced?
M1 plus M2.
So what is that? M1 m2 by m1 plus m2, right?
Yes, sir.
M1 m2 m1 plus m2. So what will be the ratio if we know this? So mu by k will be how much? Tell me. How much will be this?
1 over G times M1 plus
1
M2.
over J time.
M1 plus m2. So Kepler's law, particularly for our solar system, if we are talking about sun and earth sun system. So for sun earth system, the Kepler's third law will look like what? T square is equal to 4 pi a cube. Mu by k I am replacing by this g m1 plus m2. Now this is almost very equivalent because m1 is so less than m2. I can write it that as 4 pi a cube by g m2. Is it correct? This approximation I can do because m2 is
Yes.
much larger than m1. Poonam, can I go to the next page?
Yes, sir.
Yeah. Now, one problem related to this, let us try to appreciate and do. This is about the Halley's comet. So, Halley's comet, which passed around the sun early in 1986. You are not born at that time, so much before that. So moves in a highly elliptical orbit. So yeah, let me finish the sentence. Let me then write it. With epsilon is equal to 0.967 and T is 76 years. Yeah. So when we are like 4 5 years or even 7 8 years, so this Halley's comet was a very popular thing for us. Very popular thing for us. Everybody used to talk about that. Many postal stamps, many thing has been published on the Halley's comet. So Halley's comet was quite remarkable when we are at the young age. Yeah. So compute its minima and maxima distances from the sun. This kind of question might be there in the test what you are talking about. Answer. How do you approach this problem? Can anybody tell me? What is the data given? Let us quickly write the data given. If this kind of big wordings are there, couple of, so we have to first extract as early as possible the data. Data is given, epsilon is given as this and t is given as this, and of course it is the elliptical orbit that is also given. That is why epsilon is given. Then no need to write it, elliptical orbit. Now tell me, what is the thing? How do you compute minima and maxima distance? So what is the ingredient you need? So R mean and R max. So R mean and R max. These are the three things. Can you guess what is the relation with R mean and R max with the epsilon? We have done that, isn't it? Have we done that already? R man, R. So just tell me by saying itself the formula.
Armin is 1 by
1
C
by
into 1 plus epsilon.
Yeah, correct. So this will be equivalent to A into 1 minus epsilon. Another thing will be 1 plus epsilon. If you look at the ellipse and all these things relations, you can find it. R min and R min will be like that. R minimum will be A minus A epsilon. Another part will be A plus A epsilon. You can check it that. So quite easy. I'm not doing this. Now, if this is the case, what is the thing I need to do now? Suppose you have this is the thing given. So then epsilon is already given to you. You have to compute A from the Kepler's third law, isn't it?
Yes, sir.
Is it? Ah. So so try it as a homework. So I will not do it. Try it as a homework because unnecessarily I will. In this time I can do something else. So I will try it as a homework. So what is the hint? Hint is A. A will be how much? G. Now can you tell me, just tell me, I have just written in the previous page what is T and A relationship when the approximate thing. The last one you tell me.
So T is equal to 4 pi square.
Yeah, after that T square is equal to 4 pi square, then A
A cube by.
cube GM2, right?
Yes, sir.
So A will be what? Write down in your notebook and tell me what will be A. A will be whatever is that.
Can I see?
Yeah, tell me.
G times mass of sun times T squared over 4 pi square whole cube root.
Yeah. So G solar mass I have given is this symbol M suffix a circle and the dot. So M suffix circle dot is the notation for the solar mass, and then T square by 4 pi square, the whole to the power 1 by 3. This you have to compute, nothing else you have to do. Once you compute, you will get some number. This number you have to get. Once you get the number, epsilon already know. 1 minus epsilon, 1 plus epsilon, easily you can do it, and then you can put it and you can get it. So it's numerical problem essentially. Clear for everybody?
Yes, sir.
Let me. Yep. Now, all this knowledge.
So given all
Yeah.
the units, T should be in seconds, right?
T should be.
In
Yes,
seconds.
yeah. The year you have to convert into the day, taking 365, not 366, and then 1 day is 24 hours, 1 hour is 60 minutes, 60 minutes is equal to 60. All these things you have to count. So that is the numerical part. You have to compute that. Is it clear?
Yes, sir.
And check if you have forgotten capital G. Check your plus 2 level book or now internet, anything. Solar mass also is order of 10 to the power 3 zeros into the 30. That also you can check, and after all computing all these things, you will see that A will come, the order of magnitude will come 10 to the power 12. So yeah, of course many other things will be there. Yeah, something will be there. Yeah, I'm not writing it into this is this into 10 to the power 12. So this will come. So do it properly. Do it properly. This type of problem you can expect in the quiz. Okay. Now enough. We have talked about this elliptical orbit and all these things. So let us actually come to the qualitative understanding of the orbit, which is very necessary. Very necessary in the sense that this will tell us before we jump into the problem and see what is what. Rather, solving it immediately, we can do much more. So, qualitative discussions about the I think I will take a good amount of time to draw that. So Poonam, draw it very carefully, and if possible, try it with different colors. And Daniel, directly take this photo when you are putting in the latex.
Yes, sir.
Okay? Yeah.
Yes, sir.
Yeah. So let me put the ordinate. Is this? Mm, this is I have taken. Now in one shot, how much clearly I can draw, I do not know, but let me try. Okay, somehow I have managed it. Good. Immediately do not drop. Now let me, you see me how I am, what I am doing. Then draw. Many,
Okay.
this I will draw it here. Now I need, yeah, by that time, Poonam, if possible, whatever color combinations, if you have a sketch pen or anything like that, this is one. By the way, let me note down what is what. So this is v of x. This is x. The horizontal axis is the position, and the vertical axis is the potential, usual potential, not an effective potential. Effective potential will come a little bit later. I'll start with the easy thing so that everybody immediately can understand with the example of the simple harmonic oscillator. And then we will jump to the special cases when we will call to the central force. Of course, central inside the central force, simple harmonic oscillator is already an example. No need to say about that. Okay, then, yeah, that is the bad part. I have drawn. It should be little bit. Almost. The problem is this height and this height has come same, but my intention is the last heel height should be little bit less. Poonam, so careful about that. I cannot redraw it right now here. What I am going to do is, uh, I'm moving the cursor here. Can you see in this hill? You remove the hill in such a way that it comes below this hill. This hill. Are you getting my point?
Okay, sir. Okay, sir.
Okay, so this hill
Yes.
you put it little bit low. Of course, not very low that it should be more than this. So
Okay,
just
sir.
tilt it
Okay, sir.
tilt. Uh, yeah. So maybe this is misnomer to others, because if you are just seeing that and little bit less listening to me, it will be. Is it clear for everybody else what I said? Let me see. Can I close? Oh, if I can close it, control Z will be closing everything. Uh, okay, let me do it. Rather than, let me try to see. I'll put it on here. This is slowly. Let me do it so that. Yeah, like this. Now I think everybody will understand. Is it clear for everybody? The potential?
Yes, sir.
There are three
Yes.
distinct tops are there. These three distinct tops are there, and somehow I still managed to put this one. So this one I call, let me call that. I'll use green color. I call it as not. And next one sorry, next one I should put it. One is this. Let me take the next one. E1 is this one. So this is E1 which crosses at 2 points, and let me first write down the energy, then I will write down what is the position. Okay, now let me finish this thing at all. So there, next one it comes like E2. There I go. This is the E2. This is, call it E2. Next one is 3. And it is go up. And then I'll take E4 completely out. This is E4. Now I can come and write the where it distincts got the x-axis. 90 it is, yeah, 90. So this one, and I will probably use different color. Yeah, this one I will call it as x naught because it corresponds to E naught. It is easy notation. This is x naught. Next one is coming for E1. E1 is crossing at the 2 points which I will call XA and XB. This one I will call XA. This one I will call XA where it goes, and far away this will I will call as XB. This I will call as XB. Yo, just one moment. Yeah, this is XA. This is XB. Poonam, are you drawing now?
Yes, sir.
Yeah, good. So this is for the energy E1. For the energy E2, how many cuts are there for energy E2? 1,
4.
2, 3, 4. So I will start with C, D, E, F. So let me try from here. I'll take a different color then. So this is XC, this is XD. A little bit side maybe. This is XC, XD. Next will be X. Next will be XC. Almost there already. Nothing to do much. XE is there. XC, and then will be XF will be this portion. Okay, XF is this portion. So let me write it down, otherwise I'll forget. So I'll start with XC. This is XD. This is XE. This is XF. Okay, fine. Now E3 cuts in how many points?
1 point.
1 point. Let me take color. I've never used this color, so then me. And that will be XGEF G. So let me call it XG. XG. Yeah, I can take the scale back. Okay, go back to your position. Yeah, I'll give you. I'll do one thing. I'll immediately take a print screen and let me put it to the group so that immediately you can see this thing. What happened? The easiest thing doesn't come this way. Yeah, just one moment. Anyway, let me do the computation, then I will do it later. So I think I should not go to the next page, or should I go to the next page? What is Poonam? What do you say? Or anybody else? Anybody else? Why I am asking only Poonam? Poonam is writing that, but everybody else?
So for me, it's okay, sir.
What about the others?
Fine, sir.
Yeah, good. Very nice. So what I am going to do, let me see. It is still coming on. Wait, just one wait. I am going to upload this in somewhere else. So, by the time it comes, let me discuss this thing. Now, see, what are the situations? Suppose you are going in a one-dimensional potential, that is V of x. I have clearly written variable x so that it brings into your mind that x is only one variable. And of course, the total energy is controlled by the kinetic energy, and potential energy is equal to T plus V. So your E is governed, I mean, E is written as half mv squared plus Vx, just like that. Now, it can be, this one variable can be polar coordinate or rectilinear coordinate. At this moment, it does not make much sense for me. I kept the kinetic energy as half mv square. The interesting part is that if it is a rectilinear motion, then v will be dx by dt. That's everybody knows that. Now half mv square is equal to e, that e minus v gives the most important thing. Now carefully see what are the places. Now depending on which E you are, now these E are different E's, E0, E0, E2, E3, E4. If these are the possible cases, I have given that these are the possible cases. Now if these are the possible cases, what will happen at E equal to E? Your background thing is you are writing it in this E is equal to half mv square plus vx. That is there. Now there are different x's. I think the x is equal to x naught, xa, xb, xc, xd, xe, xf, xg. All these things are there. Now when E is equal to E naught, and the minimum at this picture, what will be your kinetic energy? What will happen to your kinetic energy? First of all, can you tell me in general? Yes, somebody is saying something. I interrupted. Yeah, tell me. Somebody is saying
E minus E naught.
E is E naught. I am saying E is E naught.
Then E naught minus V of x or V of x naught.
Yes. Okay. So let me rephrase it in another way. I need this picture in the. Okay, I think I have lost the encoder. I do not know whether it has been saved or not. Of course, it should be saved. Suddenly it has gone. I do not know. If it is, suppose if the picture is not been saved, then I do not know. It will be recorded version. It will be there, but let me put it in a different way. Why it happened suddenly? See, this is. Oh, Puno has taken the picture, I guess.
Yes, sir.
So you have sent us the screenshot, I think. Oh, Poonam has sent it.
Instead of taking now, I think what I wanted to finish it here is not possible. I have taken the picture also, and I think Poonam has also taken the picture. That is good. Uh, yeah. So let me save it at least whatever it is there, and I can start it from the next class. And lastly, what I said is that let us take the test on the Friday rather than Thursday, because by that time all these things will be finished. So what do you say, all of you? Friday is okay?
Okay, sir.
Yeah, fine. So Gautam, help me to count me who are not there today in the class. I'll note it down. Gautam, am I audible to you?
Hi, sir. Just give me 30 seconds. I'm just like going through it.
So 11, I think today is the participation.
Yes.
Time to time, all of you should check your attendance percentage. At the last moment, there will not be. If you still any problem, you can send me the message in the WhatsApp or call me and talk to me if you have any issue.
Sir.
Hmm.
So Amit,
Yeah. Then
Harita Sri,
Rita Shri.
Ankit,
Then Ankit.
Bharat,
Bharat. Then
not Bharat Khanna, just Bharat. Gayatri,
Gayatri. Then
Padmashri,
Padmashri.
Renuka.
Renuka, I think I have seen in the beginning. Anyway, put the name. Yeah.
She's,
Renuka.
and Suprit.
Fine. Thanks. Okay, then go to the. What about that? Regarding that class, you didn't say. I said
Yes,
8
sir.
classes I need.
Yes, sir. Yes, sir.
Okay,
So
fine.
we decided that November 16th to November 25th,
Yeah.
just the weekdays, so that'll give you exactly 8 days, and like from like 10 to 11, hopefully, if that works for you.
Fine. As usual classes we will go. Fine.
Yes,
Not
sir.
to.
Yes, sir. 10 to
Yeah.
11.
So I think I will try to organize a guest lecture also. I completely forgot. Only yesterday I saw the notification of the statistics guest lecture is there, and I remember that I have to also do. I'll try to contact somebody that who can give a guest lecture for this. Thanks a lot for coming to the class. Thank you.
Thank you.
Thank you, sir.